Mini batch size is another hyperparameter that no doubt you've run into a number of times already. It has an effect on the resource requirements of the training process, but also impacts training speed and number of iterations in a way that might not be as trivial as you may think. It's important to review a little bit of terminology here first. Historically, there had been debate on whether it's better to do online, also called stochastic training, where you feed a single example of the dataset to the model during a training step. And using only that one example, do a forward pass, calculate the error, and then back propagate and set adjusted values for all your parameters. And then do this again for each example in the dataset. Or if it was better to feed the entire dataset to the training step and calculate the gradient using the error generated by looking at all the examples in the dataset. This is called batch training. The abstraction commonly used today is to set a mini batch size. So online training is when the mini batch size is 1, and batch training is when the mini batch size is the same as the number of examples in the training set. And we can set the mini batch size to any value between these two values. The recommended starting values for your experimentation are between 1 and a few hundred, with 32 often being a good candidate. A larger mini-batch size allows computational boost that utilizes matrix multiplication in the training calculations. But that comes at the expense of needing more memory for the training process and generally more computational resources. Some out-of-memory errors in TensorFlow can be eliminated by decreasing the mini-batch size. It's important, however, to note that this computational boost comes at a cost. In practice, small mini-batch sizes have more noise in their error calculations, and this noise is often helpful in preventing the training process from stopping at local minima on the error curve, rather than the global minima that creates the best model. So while the computational boost incentivizes us to increase the mini-batch size, this practical algorithmic benefit incentivizes us to actually make it smaller. So in addition to 32, you might also want to try to experiment with 64 and 128 and 256. And depending on your data and task, you might have to experiment with other values as well. This is an experimental result for the effect of batch size on convolutional neural nets. It's from the paper titled Systematic Evaluation of CNN Advances on the ImageNet. It shows that using the same learning rate, the accuracy of the model decreases the larger the mini-batch size becomes. Now, this is not only the effect of the mini-batch size, but due to the fact that we need to change the learning rate if we change the batch size. If we do adjust the learning rate as we increase the batch size, we can see that the accuracy does decrease, but only slightly the more we increase the batch size. So, to sum up, for the mini-batch size, too small could be too slow. Too large could be computationally taxing and could result in worse accuracy. And 32 to 256 are potentially good starting values for you to experiment with.